My name is Marco Carloni, and I'm the founder of Linux Technologies. Simac is a linear accelerator simulator, and its purpose is to help you understand how Linux works. One of the tools that we use to teach about linear accelerators are our exercises. Exercises are virtual laboratories where you can do an experiment on a Linux and learn about them as you're adjusting the accelerator. Today, I'd like to introduce an interactive exercise where you can swap out a flattening filter and replace it with a different one. Its goal is to teach you about beam energy and flattening filters and how they work together. Here's how it works. So this is the Simac home screen, which we get at linux.ca. So what I'm going to do now is I'm going to go to the exercises section, and we access that by going to the Simac button. And here we have some choices here, and then I'm going to choose exercises over here. And this brings us to our gallery of exercises. We currently have 5 exercises on the website. The one I'm going to look at today is the flattening filter exercise. So I'm going to scroll down and I'm going to select this one. So the way the exercises are set up is that we have an overview section, then instructions, some data input, we get some numerical results, then we can look at the results graphically, and then the discussion is some questions that you can then answer about the exercise and then test your knowledge. So I'm going to go through this. I'm going to click the next button. We see the instructions. So the way this is a flattening filter exercise. So the way this exercise is configured is we have our simulator, which is set up to have pre-programmed to certain energies. So we have energies of 4, 6, 8, 10, 12, 15, and 18 MV selected. So currently I have the 15 MV selected. I can change this now. I'll change this to say 6 MV. Now we have 6 MV selected. And what we have now is in the open state is we have the flattening free filter mode. So we have over here no flattening filter installed. And we can see this if we click the next button. We can see the results. So the first screen are the numerical results, which you can then see. So this is a profile information of the beam dosimetry as well as the depth dose information. And we can scroll down and look at the numbers. If you want to, you can export this to a CSV file and analyze this yourself. Or you can go through and you can look at this on the graphical interface that we provide. And here's our 6 MV flattening free filter mode beam profile and depth dose. So what I'll do now is I'll go back and I will improve this and say I'm going to choose the flattening filter. So I'll choose this one. I'm going to slide this over, so we just bring it over, and then this will now install the flattening filter over here. We've taken it off the shelf and we've put it into the machine. So now we have a flattening filter installed. Now if we click the next button, we get some different numbers. I'll just skip through this quickly and show you the results graphically. So here we have our flattened beam for 6 MV and the depth dose for 6 MV. So the way this exercise is designed to work is it allows you to then choose different energies. So say we can choose 10 MV, and without changing the flattening filter, if we now go and see what happens, we can then go back in, calculate this again, and now we have a beam which is again unflattened. It calculates the flatness value. So here it's calculating a value of 14.6, which is a little higher than what we'd want for our clinical beam. That's at an energy of 10 MV. So we can go back again, we can try to fix this. What I will do is I will install this flattening filter over here. When you do that, it puts back the old flattening filter on the shelf and installs a new one. And so of course we don't tell you what flattening filters associate with which energy. That's part of the problem of the exercise, is to try to understand that. These flattening filters are divided into 2 groups. There's ones made out of tungsten, and there's ones made out of copper, and they have different heights, which you can see, which are represented by the icons. So if we go and do this one, and we calculate this, we have a flattened beam, because I chose the flattening filter that was designed to match the 10 MV beam, and now I see our flatness number that it calculates is much better. If you then, once you're happy with these different combinations of flattening filters and energies, you can go through and then we have a discussion. So we have a number of questions that you can go through, and we have some questions you can answer. You can enter your answer, and then when you're finished with that, if you want to make a record of that, you can export your answers to a PDF file. So we do this, and what that does, it'll download that, and then when you have is you see the different questions we've asked, and then there's the answer you provide, and then the answer that we provide as a system, and you can compare your answer, your question, to the answer that we provide. So this is the flattening filter exercise from that we provide with Simac. Currently there are 5 exercises. There will be many more coming in the weeks and months ahead. And we hope that you find this enjoyable and that it'll be an interesting way for you to learn how Linux, how their beam flatness works with energy.